That was a great introduction. Not static as in bad, static as in great. All right, so I'm going to try to use my phone as a controller for this thing, and hopefully it'll work. So I'm not taking out my phone all the time to check text messages, just so you know. Taking it out to try to look at my notes and control the slideshow. I usually just like to dive right into talks and do introductions and stuff later, so let's do it. And this is going to be a very architecture-heavy talk. Let's talk about web architecture. In this talk, we will be comparing and contrasting two different types of things you can make for the web a lot. The first one is web apps. And so just to clarify what exactly that is, a web app is something where you have a very, very large number of unique views. Typically, it is something that's highly interactive. And usually the easiest indicator of whether something is a web app or a website would be if you have users. If you have user logins, user profiles. As soon as you have users, your number of unique views becomes absolutely enormous. And we'll get into why that makes a difference in a little bit. Twitter is going to be my standing base example of a web app that I'll use for like talking about examples. But just know that I know very little about Twitter, and I'm just using it as purely an example, and it does apply to any other web app in a similar way. The second type of thing that we'll talk about today is marketing or informational sites. And we all know what these are. There are very, very many more of them on the internet than there are web apps, surely. This is a website that's not intended to be a tool where you can accomplish something, but more a presentation of information. So whether that's about a company, whether it's about something that you're researching, et cetera, they're very much in a different category than a web app would be. And that's about all I got. And yeah, sorry. So I will be using my own wonderful employer, HashiCorp's website as an example of this because I work on their marketing site and I know about it. So why not use it as an example? All right, so now I'll do the introduction. I am Jeff. I like to climb things like trees. I work at HashiCorp, as you know, and I am a dev lead on the marketing team, so I don't work on their deployment tools, but I work on all of their public-facing presentation. I like to make furniture in my free time, and that's something I'm happy to talk about later if anyone else is into that. I also have a pet bunny, and she's very cute, and I'm happy to show you pictures of my pet bunny afterwards as well, just trying to, make it so that people will talk to me afterwards. That's all. Any more questions I can answer later. So let's just start with a baseline. You're trying to build something new, a new type of something that you're going to put on the internet. The very baseline that I'll go with is try to make it static if at all possible. And if it's not possible, then you might have to resort to falling back to other ways of building things. And so why would you make it static if possible? This is surely something you've heard before, so I'll try to kind of breeze through it. But technology for building web applications has changed very frequently over time and is fairly unstable on the whole, whereas technology for building static sites has pretty much been the same for all times. It's HTML, CSS, and JavaScript, and it's very doubtful that it will change anytime soon. So if you make a static site, it's very likely that that site will be in its same form 20 years from now. And it's very likely that if you look at a static site that was made at the very beginning of the internet, it will be perfectly manageable and accessible to any front-end developer because it will probably be made with HTML, CSS, and JavaScript. You might have to take out some tables, but other than that, you'll be fine. This one also, everyone already sort of knows, but a static site has a very small attack surface. Since it is simply a file that is served to the user, there aren't really many ways that you can take advantage of it. It eliminates a lot of concerns when you're using a static site because you don't have to think about whether someone's going to be able to hack into your database, put ads on your site, steal your user data, etc. And you can fight me over this if you want later, but I think I have pretty good justification for it. Ultimately, a static site is going to get the best performance that you can possibly get because it's not doing anything. You have no things to think about. You have no logic. Your server is making no decisions whatsoever. You make the request for the web page, your server pulls the file, and it hands it back. That's a static website. Any other type of website, your server is doing something else. It's asking the database for some information, it's compiling a file, it's going to find a user profile. That thing that it's doing takes time, and that means worse performance. So if you're looking for the best possible delivery, the fastest possible delivery, it's going to be get this file and serve this file back because it's simple, right? All right, so the problem is that a lot of the time, the thing that you're building cannot be a static website, right? If you are building something that's an app, you really cannot make it a static website. If you're talking about Twitter, for example, there's no chance that Twitter could ever be a static website. There are millions and millions and millions of unique views. They change every half second, or probably less. And there's just no way that you can have a static compiler running through all of those things. And so what I'm trying to lay out here is basically you want to make a static site if possible. The initial goal when you're starting a new project is, can I make it a static site? Because there are a huge number of benefits to making it a static site over having to build some server logic. If not possible, then we move on to other considerations. And I'm not sure if a lot of people see it like that off the top, but that's definitely the way that I see it. Are there any questions about that or comments before I kind of move on to the next section? Yeah, we'll get into that. We'll get deep into that. Yes. Anything else? We good? Okay. Oh, there was. I'm sorry. Go ahead. I would say so. There are a number of companies that provide API-based e-commerce, like headless e-commerce. Were you saying speak up? Huh? Oh, I'm sorry. Yes, repeat the question. The question was, what would you do about something like an e-commerce site? Would you make it static or dynamic, roughly? And I think it probably would be the same framework of evaluation. Could you make it static? And I think for most e-commerce sites, the answer is yes. Similar answer for most blogs. Unless you have some really complex functionality, you can probably just use an API, load the page by default, and then render those buy buttons once JavaScript renders. When you click it, shoot it off a request to the API, and then you're static. I mean, you're not 100% static. You're still communicating back and forth with an API because it is sort of an app. But you can definitely get the front end done as static, and I've seen it done before several times. I think Snipcart, if I'm not mistaken, is somewhat of a market leader in that area. And they have a lot of blog posts that they do on it. Okay, was there anything else? I thought I saw a hand somewhere. Okay. Cool. So let's go into some web app architecture because we just went over static sites. And this is just more enormous amounts of context before we get to what I'm actually trying to talk about. So a lot of apps really genuinely could not be built as a static site. And this is sad, but it means you have to think about what other options you have on the table. And so we'll take a little walk through history. This is kind of coincidentally in chronological order. And we'll talk about some of the different major ways that web apps have been architected throughout time. So the first one is to render it 100% on the server. And this is what was going on in the PHP era and what was going on in most, if not all, of the Ruby on Rails era of web development. And that means that the user asks for the website, the server goes to the database, collects views, compiles together the result, sends HTML back down, and you get that HTML, and that's your page. There's not really any logic on the client. It just renders off of the server. If you click on a button to take some action, it makes a request to the server handles it renders a new page, and it sends it right back to you. So there are pros and cons to this. The pro is that it's really simple. You don't have to put any logic on the client. Your server handles everything. You just put it on the server. The request goes to the server, you send back a page, and you're done with it. The con is that the interactivity on this type of site is extremely poor. If you could imagine something like Gmail being built as an 100% server-rendered site, it would be really slow because every single time you click on a new email thread or click back to inbox, you get a full page render. And there are some types of apps where it's just not feasible. The apps rely on being interactive and fast and native-like. And if that's the case, you do need a full page render every time that you take an action on a server-rendered website. So it's just not viable. Somewhere where it is viable is something like WordPress. And WordPress is an 100% server architecture, although I feel like they're doing some React thing these days. Traditionally, it's been 100% server. And so the way it works is you go to the person's homepage, WordPress goes to the database. We're going to ignore caching for now because that will really muddle things up. WordPress goes to the database, finds all the posts, renders them into your template, and displays the page. When you click on one post, the server takes the post ID, it renders into your template, and it sends it back to you. And that's totally fine because you don't need instant responses and high interactivity. And it makes everything much simpler because you don't have to deal with a lot of client logic. So there's 100% server. Let me see if there's anything in my notes I missed. Nope. Okay. The next option, and incidentally, the next step through web app architecture history is the 100% client approach. And this era started coming into play near the end of the Rails era and sort of when Backbone started becoming the thing to build apps with. And this was just pretty much an entire reversal. So with the 100% client approach, what you do is you send more or less an empty HTML page that contains a script tag with a bunch of JavaScript. The JavaScript loads up, it hits up your server, which has been stripped of all its rendering logic and basically turned into an API, gets your data back, renders it into a template on the client side, and displays that template on the page. The bonus of this is that there's really great interactivity. Because you're doing everything on the client, you can respond very fast. You don't have to reload the entire page anytime the user takes an action. If the user clicks like this tweet, you can just fire that off to your backend, and you can immediately say, it's done. You know, the heart lit up, you've liked the tweet, and in the background, it completes, right? It's very fast. It almost seems immediate, which is awesome. The drawback here is that you have an extremely low and slow initial render. So the problem, like you might have heard when I was explaining how this works, is that there are a lot of steps before something can go onto the page. So the page gets sent as a blank HTML page, the JavaScript parses, the JavaScript executes, the JavaScript goes and asks the server for some data, the server processes, figures out what data to send back, sends the data back, the JavaScript receives the data, renders into a template, and then finally it puts it on the page. It takes a lot longer to do that than it does to hit the server renders it, and sends it right back to you. Also, there are a couple of SEO drawbacks to it. When you're shipping an empty HTML route, web crawlers can't really see the contents because they don't evaluate JavaScript, and neither can like social sharing sites or anything like that. Sorry, let me go back. I gave it all away. So Twitter actually operated both as a full server-rendered site, and at one point it also operated as a full client-rendered site, because initially it didn't have things like a live updating feed, it didn't have things like reply threads. It just pretty much was go to the site, the server renders all the tweets, refresh the page, it renders your updated tweets, click on one tweet, it renders the view page for that tweet, and it worked pretty cleanly. After a while, they started wanting more live updates, more interactivity, so they swapped everything over to 100% client. At that point, they were shipping essentially an empty page and doing everything via API. The problem was that it ended up being too slow. So they got rid of that architecture entirely after a while, because while 100% client worked out for a little period of time, it kind of intersected with a time when mobile internet was becoming a really big thing. So people were starting to see mobile traffic on the rise. More people were getting access to mobile phones. And this is a really big problem for an architecture that puts all of the work into your browser. When you have an old phone with a poor internet connection, the slow initial render magnifies itself to extremely slow initial render, and you'd see sites loading on average 3G connections and average Android phones, which is the most common way to connect to the internet in the world, like 10, 20, 30 seconds. Especially when someone's on a phone, they're already distracted. You're not sitting down in front of your phone and focusing only on that. You usually have it out while you're doing something else. So you'll see a big loss in conversions, big loss in business. People will just leave the site. It takes 30 seconds to load. Don't have time to just sit at your phone for 30 seconds, right? Who does that? So 100% client started taking some hits. And now we've moved on to this final solution, which is server-rendered React. And so I know that some people are finding this boring because they already know all of these things, but I want to explain them all to make sure everyone's on the same page. So bear with me, and hopefully this is helpful. So the way that server-rendered React works, and I would like to preface this with a note that I am not a React enthusiast. I don't want to get into the whole front-end frameworks war. I simply use the term React to apply to everything that's similar to React. So if you like Vue or you like Angular or whatever, like there's 1,000 other ones, just imagine that that's the word I'm saying. I'm just going to use React to refer to all of them rather than saying 20 words every time I need to say the word React, okay? Everyone good? So the way that you would write a server-rendered React app is that you would write code using React such that it would run on the client side, and you would send that code to your server and your client both. Your server then takes that code and it uses it to render simply the initial view of your app, only the first view. This is a very difficult thing for engineering teams behind React and other frameworks to accomplish, but they did it. They have it such that you can put React code in a server and you can render out the HTML that would result from your app. So when somebody makes the request to your site, what happens is the server will take your React structure, it will render out some initial HTML from it, it will send it down the wire so that you get a fast initial render, right? The page shows up just the same way that it would if you used a server-rendered site. That same logic also gets sent down the wire, and after your site loads, the JavaScript starts firing up and making things interactive. So you kind of get the best of both worlds. It's almost a compromise between the two. The bonus here is that it's overall fast, right? It has a fast initial render, and it has fast interactivity, which is great. The downside is that it's unbelievably complicated. You have a server and a client, you have the logic running on both of the above, and both of the environments are distinctly different. So you need to write your logic such that it doesn't break on the server and it doesn't break on the client, and it cooperates between the two effectively. And for big companies that really need performance, this is obviously worth it to make as a trade-off. But there are a lot of situations where it's very much not, because it's really difficult to manage this type of thing. All right, before I move on to the next section, any questions about this stuff? And I very much apologize if I bored people by this, but it was really important context. Twitter. Yep. If you go to twitter.com, it uses this exactly. And you can put your browser on a simulated slow connection, and you'll see that it runs really fast. But it takes a second before the page gets interactivity because they give you the HTML over the wire. You can view source, and you can see the HTML comes out by default. But twitter.com is managed by... It's a React app, and it's a server-rendered React app. And their team has a lot of really cool posts about how they built it. There are a lot of other web apps that use this approach. Almost any large company is going to use this approach. Not necessarily with React, but the architecture pattern will be in use because the performance advantage is so large. Yeah. Other than Twitter, I mean, I could try to dig them up, but I don't have a list of examples off the top. I can assure you that there are a very large number of them, though. I mean, if you find a well-funded company that's using React, they're using server-rendered React, for sure. Yeah. Yes, web applications, for sure. Yeah, sorry, this was our tour of web application architecture. Yeah, all the way back. That's a good question, and I'm sorry for not repeating them. The question was, is Twitter using a node server to render it? I am almost positive that they are, because React is a JavaScript framework, and it requires a JavaScript environment to compile. So I would say with very high confidence that they are, but I don't know it for an 100% fact, so I could be wrong, possibly. Typically, server-rendered React is run using a node server, for sure. Yeah. Well, I must have heard more recently than you, because they certainly are using, for their mobile site, for sure. Yes. They have a bunch of blog posts on it that I would highly recommend, and they're really good. And sorry, that question was, I heard that Twitter was using Ruby on Rails. And they did use Ruby on Rails for a very long time. And they might be using it still for their desktop site, but I know for sure for their mobile site that it is using server-rendered React. Anything else? Okay, cool. Let's keep doing it. Was that like helpful, or was that something everyone knew? Okay. It's hard to get feedback, you know. You just say things and like you hope for the best. Okay, good. You guys really make me feel at home up here. Okay, so let's get back to static sites, because I know that this guy wants to talk about it, and I know that a lot of the other people here want to talk about it. I said a short overview of web app architecture. That was actually pretty long. The static site architecture one will be a little bit shorter. You can probably see after this large trip down the rabbit hole of changing architectures and complexity, why you want to make a static site if you can. Because static architecture has never really changed very much at all. There's one thing of note that's happened recently that I'll talk about, and this might bring me under fire, but we'll see. I also want to note that while you might not be able to run your web app with a static architecture, you almost certainly can run your marketing page with it. And every web app has some kind of marketing page, because if a product exists, it needs marketing, because otherwise nobody will hear about it. So while I know that a lot of people are employed working on web apps because they're way more complex and require more engineers to work on them, there still are a lot of people that need to be employed to work on the marketing, and the marketing side of it is just as important to the success of the organization as the web app itself. If nobody comes to your web app, it'll fail. If people come to your web app and it's horrible, it'll fail. So they're kind of equal balance, but since web apps are so much more complex, they get way more engineering work, and they get way more coverage in talks, which is why I try to focus more on some of the marketing stuff in my own talks. And also, that's my job, so, you know, bias. So the one thing of note recently that you could say has been a bit of a change in static site architecture is that you'll find a lot of React-powered static site generators that use precisely the server-rendered React pattern in order to build out a static site. And surely some of you here have used them. Surely some of you have heard of them. There are quite a variety of them. I think probably Gatsby would be the most well-recognized one, but there are a number, and they all work very similarly. The problem with these is that they use an incredibly complex software pattern to solve an incredibly simple problem. And it confounds me. Why? Because you don't need it. So let me go into my plus and minuses of this approach here. The plus is it uses React, and people really love React, and React is really cool, which is fair. The minus is that you don't need React for this. and so it's a little bit confusing why it's become so popular. And I have a couple of theories as to why, and I don't think that they're totally worthless or bad to use, because there's hardly anything in that category. But I think that there are way fewer situations where they're appropriate than our current implementations of them. And after talking to a lot of people that use them and work on them, I think that the right use cases are a couple of them. One is that we've come into a generation of developers where there are some developers that are genuinely more comfortable writing React code than they are writing normal JavaScript and HTML. And for people that have been writing code for a long time, this will probably sound confusing or baffling, but it really is true. I guarantee it. I've spoken with a number of people like this. I'm sure there are some people in this room that are like this, and it's totally fine. If you have a development team that is more comfortable writing React than they are writing not React, then that's a really good use case for a tool like this. It's obviously the right fit for your development team. And whether or not there are some drawbacks as far as complexity, performance, the fact that other tools will come out and you might have to re-architect in the future, if it's the right fit for your team, then it's the right fit for your team. So yes, go ahead. That is a good question. The question was, what is the difference between a React static site generator and server-rendered React architecture, which I definitely should have covered, so thank you for asking that. The difference is with a React static site generator, it will do the same thing with React as far as like having it run on a server and having it run as a client, but instead of you running your server in production, it will compile them out into static pages instead. So it's not viable for something like Twitter, where you would have 10 million static pages to compile and it would take forever. What is happening here? I won't ask questions. It's not viable for a web app to use a React-based static site generator because you have too many pages and they change too fast. But for a smaller site that has fewer pages, it's within the realm of possibility that you could use it. And so it does use the same architecture pattern, but rather than when you hit the site, a live server compiles your page on the spot with the most recent data and sends it back. Instead, you do this at build time. So you take all of your pages, you generate them at static at build time, and then when the person hits the site, they get the HTML, React comes in, it runs itself on the entire site because the whole site is built with React, and it makes every component into a client-side React thing. Does that make sense? I'm sorry if it doesn't. Okay. I guess I was talking too loud. Okay, so there have been jokes about this type of thing throughout history, about every wildly popular and more or less defaulted web technology. And this is one of my favorite ones about JavaScript. And I like this a lot because it's satire, but it's not mean, and it's funny. And it's a Stack Overflow question where somebody is asking how to add two numbers together, and everyone chimes in and pitches in these solutions of how you can use jQuery to do it, and how there's a jQuery arithmetic plugin, when in reality, you just do number plus number. A lot of the time, if you jump to an incredibly complex client and server side, like component-based solution for something that could be raw HTML, you're putting yourself in the same spot. You're using a really cool, popular technology, which is amazing, and jQuery is amazing, right? But you're using it when you just didn't need it. You didn't need it to add two numbers. You don't need React to render your personal site that has a paragraph about your life and a blog, you know? So always worth keeping in mind. And I'm not picking on React here. I'm not picking on static site generators. I'm not picking on jQuery. They're all amazing technologies, but they have times and places where they're appropriate to use. And sometimes people just get really excited about cool technology and try to apply it to everything. So it's important to think about when you're applying it. Ultimately, what you want when you're building your site, and this is kind of like tying right back to do a static site if possible, is you want the simplest, most sustainable, and most performant architecture that you can think of to build your site on top of. That means something that is easily understandable to the largest number of developers possible, because that will help your team to understand and work with it, and it will help you to hire better for people that come in to work on it once you grow and become successful. You want something sustainable, meaning it's not something that will go out of fashion in a couple of years and you're going to have to rewrite it because it becomes obsolete. At this point, if you find a Backbone app, a lot of engineers won't know how to work with that anymore. At the time, Backbone was the absolute best solution, and everyone knew how to work with it. At this point, it's becoming obsolete, and people who wrote their things on Backbone are going to have to start migrating them over. So ultimately, you want to bank on tools that you know will be sustainable for as long of a time as possible. And finally, you want it to perform well. Obviously, we're at the Web Performance Meetup. Everyone knows this. But don't overcomplicate your stuff for technology's sake. Use the lowest baseline you can and get it to perform as quick as you possibly can. Cool. All right. Anything before I move forward? Okay, let's do it. So now we're back to the original question. I've been comparing, contrasting web apps and static sites for a while, and those are on very much opposite ends of the spectrum. What happens when you're sort of starting to fall in between the two options, right? You have a site that might be static, but there are some areas of that site that really are very interactive, and it's getting to the point where maybe like you're starting to write two-way data binding JavaScript logic. You start to feel like you might be replacing parts of React. It's starting to toe the line between like where you have a marketing site and where you have like an app. If you got users, that's all the way into app. But there are some sites that could be static, but they have portions that are highly interactive, or they need to communicate back and forth with an API for some sections, right? So at that point, what do you do, is the question. Do you go to server-rendered React? I mean, you could. Do I have drawbacks? Yes, nice, okay. The problem with this is that it's way too complex of a solution. You didn't need a server in the first place. Your site was originally static rendered. You didn't need a server, and you just introduced a server so that you could get React on your site. That doesn't seem reasonable. It's a lot of work as well. Okay, so what if you just put React on the client side? No server-rendered React. You just use regular client-rendered React. And you use it for those portions of the site that are interactive. This is okay, but then you run into the same drawbacks that you ran into with a 100% client approach. You've got your slow initial load, and you've got your empty HTML where you're actually trying to render that interactive content. So you have losses on your search engine optimization, you have losses on share, and those drawbacks kind of suck. So you can eliminate those by using a server, but then you've got the other problem. So do you use a React static site generator here? That's the other question. This is close as well. In this case, you get the logic server rendered effectively for you. You get React on the client side. That's cool. But ultimately, you're ending up with a lot of work having to do this. You have to go back and convert your entire site to React, including all the sections that genuinely do not need React at all. You also put yourself into a spot where you're 100% invested in React or whatever other tool it is. So if that changes, if it's starting to become obsolete, you're going to have to rewrite your entire site. And all of your engineers need to be 100% comfortable with React to even edit a basic text paragraph on your About page, right? Because that's how these things work. You're all React or you're not. There we go. There's the thing I put in the slide that I should have pulled up earlier. You're making your entire site React for just one small part. So this kind of bothered me because I ended up working on a lot of sites that were in this kind of middle zone. And so I made something that I think helps to work it out. And so that's what I'm going to talk about here. And I really don't know what to call it, but I'm just going to call it static rendered components. If you have a better name, I'm very much open to them, but that's what it is. So I'm going to explain what this is using examples of code rather than just telling you about it, because you've already been listening to me talking for a while and several people are sleeping. So let's get right into let's get into the good stuff, unless anyone has questions beforehand. All right, cool. So if you're making something with a component, you must start with the component. So here's a very basic component. This example uses Preact. The reason for that is because it's a smaller library and reduces your initial load time. For simple applications, it's more than sufficient. And it has an identical API to React. So if anyone's used React before, this will be pretty straightforward. It's a component that renders a paragraph that says hello to the name prop that you pass into it. All right, so we have our component. I will link all this together, I promise. Then you have some configuration here. So most of this won't make a ton of sense, but I'm just going to point out the part that does, and it's this part. You've got some type of build process for your static site, as most people do. And in the build process, we have some pairing between a string here, my component, and an actual component. You can see that gets imported up here, and we're presuming that this is that component that we just looked at. Okay, so we have the pairing between the string and the actual component. Here's the markup, okay? And the markup, we have a custom element that the name of the custom element, you can see here, is that string. And it takes props, a lot like a React component, but it still is 100% regular HTML. It's just a custom element. A lot like a web component, actually. Here's the results. So it renders the component out, it replaces the custom element with a fully rendered component. And you might say, you know, Jeff, that's really great, but why didn't I just write the HTML in the first place? This is worthless. It just gives me a chunk of HTML. You can rehydrate it. So this is in your client-side JavaScript. You import the same component that you put in there originally into your config, and you can render it out. There's your component. The first parameter is your component markup. Second parameter is the parent element, and the third parameter is the element that you are aiming to upgrade with interactive React capabilities. And we're using the selector my component because that's what we put in here. Can you see my mouse? Oh, nice. That's what we put in right here up top. Cool. So the benefits here are that you get it rendered out to static. So you have a very fast initial render. You have no SEO problems. You get interactivity. It rehydrates the element and runs it on the client side. And you don't have to convert your entire app to using React. In fact, you don't even have to use React for this. You could use whatever framework you want. I just have this example using Preact. And you'll see why that's the case when we go into how this works. But before I go deeper into how it works, does anyone have questions about this? Because I know it can be a little bit confusing, and I would be happy to clarify. No? Wow. Yeah? Oh, yes. That is a good question. The question was if I could explain rehydration. So the theory behind rehydration is that, so let's say that you have a rendered component already on the page as HTML, and you're telling React to make that component interactive. One way you can do it is say, render the component into this space and delete everything that's there. That would be fine, but it would be better if you could say, hey, I already actually rendered the initial state on the server. Can you just look at that initial state and then change anything if it's necessary, and if not, just attach the event handlers without having to re-render. So that second approach is rehydration. It takes an element that's been rendered to static HTML on the server, takes a look at it, decides if it needs to make changes. Most of the time it doesn't, because that was the initial state, and then it does the event attaching without actually updating the HTML at all. Thank you for asking that. Anything else? Yeah. That is not the wrong impression, but Gatsby does not use HTML. Gatsby does not look like that. It looks like 100% React. And it uses React to render 100% of your site. So here, I could put in some normal HTML above that, a couple paragraphs, a headline, not an issue. Only that one component is rendered and rehydrated using React, and my whole site is written using standard HTML, CSS, and JavaScript. They're similar in that fashion of how it does the rehydration, but it's not quite as invasive. Anything else? Cool. All right, great. So let's talk about how this is made and some of its applications. There's a cool tool called Reshape, which I also work on, and it is effectively the Babel for HTML or PostCSS for HTML. That is to say, it's an HTML parser, and it gives you the ability to write a JavaScript plugin that receives an HTML parse tree. You can modify that tree in any way you want, and then pass it back to Reshape, and that generates it back into HTML. So out of the box, it does nothing. It parses the HTML, and it generates that same HTML back. But you can throw a step in the middle where you make modifications to the HTML without having to write your own HTML parser. It gives you a nice nested JavaScript tree, and you can do what you want. This is exactly the way that PostCSS works. It's exactly the way that Babel works, but it's just for HTML instead. That's what's used to process this. With that context, we can go back and look at the config and have a little bit more understanding of what's happening here. Our static site generator, whatever it is, we'll get into that more later, uses Reshape, and we pass to Reshape's configuration a plugin that's called render components, which we've required here. This plugin is a piece of JavaScript that receives a parsed HTML tree and returns a parsed HTML tree. It walks through that tree and looks for any instances of any keys in the object that you pass to it. If it finds one, it takes the value, it renders that component to string, and it substitutes it in place. You can pass as many as you want. So it's really not a very complicated piece of code, and anyone really could write it. It's just that Reshape didn't exist until recently. Does that make sense? Okay. So it's really not a lot. The rehydrating is actually pretty complicated, but like the basics of it is fairly straightforward. Also, did anyone spot a mistake in here? Because there is one. Did anyone notice it? All right, you sure? You want to look again? Let me give you one more chance. Now that you know there's a mistake, I'll give you, we can look at these slides and see if you can spot where I've made an error. And I'm not talking about a syntax error, I'm talking about like an architectural error. Here's our component. Here's our configuration. Here's our markup. Here's our results. And there's the upgrade. There's something in there that seems a little off. It's not a syntax error. No. It's an architectural issue. Yeah, sort of. The problem is that there's duplication in here. This isn't dry code. Right here, I have my component code and I have my props. Right here, I also have my component declaration and my props. Can you imagine what would happen if I had 10 props? I would have to repeat all 10 of those props in my HTML and exactly the same props in my client-side code. If there is any differences between them, the page would render with a component and then React would take over and notice that it was actually different and it would re-render that component with different properties. Maintaining those two things, if you've got 20 components that each take 20 props, is really bad, right? There is a fix for that because that would drive me crazy. And the fix is that, I'll show it to you later, but the fix is effectively that with any component that's rendered, the framework injects an extra prop called initial state, and you can attach that initial state to the top level of the component, and when you rehydrate it, you can pull it back down and pass in instead of this line here, you could just query selector the component and do data initial state, and it would reconstruct the initial state. And I'll show that to you in a little bit. That's a little confusing. That's why the rehydration is a little more complicated. But I just wanted to assure you that there's not a large gaping hole in the way this is made that requires you to repeat yourself gratuitously. Okay, any questions about Reshape? I mean, I can also take them after, but if there are any burning questions, I'm happy to take them. So I was asked to come here to talk about Spike, and I spent the whole time not saying anything about Spike at all. So I'm really sorry for fooling you, but I promise it's still relevant. So I just had to build up, like a solid 30 minutes of context before I got to it. Spike is a static site generator that I work on. It's open source. It uses Babel, PostCSS, and Reshape. All three of these things do nothing out of the box and allow you to write plugins to modify HTML, CSS, and JavaScript. They align very much fundamentally in their view of how things happen. So it doesn't force upon you a specific language or set of constructs. It gives you a foundation that's more or less empty upon which you can build up the way that you want your HTML, CSS, and JavaScript to be processed. Spike itself is a big Webpack plugin. It's not its own thing. It just extends Webpack to compile HTML and CSS in addition to JavaScript. So it doesn't touch the JavaScript, so if you've written a Webpack config file, first of all, I apologize. And second of all, it will work the same with Spike. It just adds the capability to also run HTML and CSS because at its core, Webpack is a compiler of code. And it can compile JavaScript. That means it can also compile HTML and CSS if you force it to do really weird things using a plugin. All of the examples and implementations of this static rendered components are written using Spike. All of the examples and the syntax in those are Spike syntax. And I have a few live examples that use Spike as well. There are many static site generators. They're all wonderful. I made Spike because I needed something that was unbiased. I worked at an agency for about 7 years, not a product company. And we had clients coming in with all sorts of different asks. We couldn't say, hey, we make React websites, and that's it. If they wanted something different, we were going to give it to them 100% of the time. And some of the sites would be giant, some of them would be tiny. And so subscribing to one philosophy and not budging was not an option at this company. And so I don't like writing new code unless there's no other option. But in this case, that was what it came down to. So if you are interested by the concept of starting with these parsers and building it up, or you have very flexible needs for your development, this might be a really great tool for you. And if not, then maybe it actually won't be that great of a tool. So, check it out, see what you think about it. It's open source. You can look up Spike static site generator on Google or something, you'll find it. This is in production. Spike's in production pretty widely. It has been for years. This exact component pattern is in production, and it also has been for years. It's in production on my employer's marketing website, which is HashiCorp.com, and I'll show you what it looks like in just a moment, and I'll show you a couple of interesting ways that we've used it, as well as some examples. That's all for the portion where I talk and not where I show examples, so I'm going to say thank you for listening to all of my talking, and I'm sorry it was boring or tedious. There are several URLs here. The first one is these slides. So the URL, luckily, is very easy to remember. It's slides.com/myname, Jeff Escalante/static render components. The second one is an example repo of a full implementation of this. It has 3 components. One of them is 100% server. One of them is 100% client. One of them is static component style. So you can see how they work, see how the code's written for them, test them out. And the website where the result of that experiment is this bottom URL. So we'll go look at that in a second, but I just wanted to at least give you the URLs in case you need them. And I'm pretty sure that these slides will go up on the video or the website or something, so you don't need to furiously copy these down. I just wanted to make sure they're in there. All right, so let's go look at some examples. Oh, that's not what I expected. I guess I need to exit full screen. All right, so let's go to this one. Oh no, what have I done? Okay, let's go to this one and take a look to see our code in action. Is this visible or do I need to boost this? Is that better? Okay, so this is kind of the example I was talking about. So component rendered as only static HTML shows up top. And this one has a button on it that has a counter next to it that counts how many times you click the button. And when I click on this, it does nothing because it's static HTML. So it can't do anything, which is perfectly reasonable. The next one is a component that's rendered as static HTML and upgraded on the client side. This is a static rendered component. We'll look at the source in a minute. This one works perfectly fine. The last one is a component that's rendered only on the client side. There's no server rendering, there's no static rendering. It's a blank HTML div that has JavaScript render component into it. This one also works and counts up, as expected. If we look at the source, React DevTools does work on here as well, which is a good note. We can see a couple of things here. Here's our static-only element. You could see this one looks pretty reasonable. It's got all of the code in there, doesn't have any JavaScript, doesn't do anything, but it looks nice. Here's our static render component. You could see some gobbledygook up here. This is the initial state. So this is the trick where you don't have to repeat yourself. It takes basically what you put into your HTML, that straight HTML representation, and it serializes it into a React version of itself, and it saves itself on the element, base64 encoded, so that you can pull it back and not have to rewrite it a second time. And inside of it, you can see the full thing is rendered out. All the HTML is in there. That'll show up in search results, and it will render on the page immediately. Here's your client-side one. It's empty. This is client-side only, so you see no HTML. This might be minified. No, I don't think it's really worth wading through this. Let's go to the repo, and then we can see what the code looks like at the source for clarity. And this is a Spike project, conveniently enough. So here we go. There again is my component. There's our component up front. That's the one that we static render. You can see this whole thing here. And do I have another branch where it's complete? Rehydrated, maybe? I don't know where the other one is. Yeah, no idea. I guess I blew it. Let's go to the config, and then I'll look at the script. So here's the config. Here's the same library that we saw before, render components, and here's the render components call. Pairs up my component with my component, which is required up here. So I won't really put you through any more of this misery because I assume you trust that this works as it works, but I kind of just wanted to show you in a real chunk of code and on a rendered website what it looks like. I'll also show you an example from my company's website, which uses it pretty extensively. The nav and footer are both rendered using this, and you can see they showed up pretty quick. I've got a really complex client-side form. As you can see, most of this page is not interactive, it's information. So running this all with React would be a little bit ridiculous. I'm gonna put in my email here. Wow, that's a fail. Now you all know my email. This is very hard typing with one hand. I apologize for the brutality of this. Wow, and I even misspelled it. Okay, did I make any errors? Yes? Oh, cool, thanks. So if I hit this, it will go into this kind of interactive form experience. And this is entirely built out with React because it's very complicated. You could see that I put in the email, it passed it through the URL, it loaded it into this field. It went to the server, ran that email past Clearbit, found out who I was, and then filled in the rest of the form fields that it could. If I change this to something like gmail.com, it would do the same thing, and it would give me a little warning message saying, hey, this looks like a personal email. The reason this warning comes up is because when somebody reaches out, they want to know what company that person's from, so they can say, hey, 2 of your coworkers already reached out to us about this, etc. Pure utility. If you come to this page from a Chinese IP address, it will put up a message that says, I'm sorry, we're having legal things we need to go through, and we can't sell software legally to people in China. There's a lot that's going on here. and it has multiple pages, multiple states. You can select these options, and what it will do ultimately is go hit the server, generate a fresh license key, and here's actually a fully functional 30-day trial of HashiCorp Vault if you want to use it on the spot and immediately. This kind of thing would be really hard to pull off with just regular JavaScript. It would be really brutal, and the fact that we could use React for it and still have this site rendered super fast and clean was a really big advantage. So there's an example of it in action, and I'm happy to field any extra questions now or leave if I've already been talking too long. Yes. The question was, have you benchmarked these three approaches? The client-side only version, it's literally impossible that the initial render is faster than one that's rendered on the client side because there's nothing there. And the one that's client-side only, it's just not interactive at all, and so it's worthless. So I have not, because I didn't feel like I needed to, you know? Although I would very much welcome anyone to do it, for sure. Yeah, so that's a good point. Do you have more? Sorry. Do you have more? Sorry, did I cut you? Okay, so a short version of what he said was, when you're slicing and dicing and comparing these types of approaches, your performance difference might be in the order of, milliseconds, hundreds of milliseconds, whereas the development time differences could be many hours. Very, very good point. And for that reason, it's worth evaluating this within the context of how your company operates as well. 100 milliseconds is easily millions of dollars of revenue for a company like Amazon or Facebook. For a smaller company, it probably isn't. So whether or not you take on this approach depends a lot on the general framework for making business decisions, which is, we can do this thing that makes this improvement. Is this improvement worth the amount of time it would take to make this improvement? I think that the reason this kind of favors the approach that I was talking about is that it's a lot lower of a barrier to entry to have a website that's built with HTML than it is to have a website that's built with 100% React and only have React elements in spots where you need React. For that reason, I would say if you're evaluating the effort level of implementing something, generally it's going to be lower effort if you use React only in the spots where you need it versus using React for everything. But of course, that depends on your app, right? Yeah, sorry, is that okay of an answer? Okay, sorry, yeah, true. Quick summary is 100 milliseconds isn't always 100 milliseconds. It can vary pretty widely. You have to benchmark it, and obviously it depends quite literally on the internet connection speed and the CPU speed of your device, especially when you're talking about evaluating JavaScript. Typically, you would test a mobile device with a 3 to 5 times throttle on your CPU, and a very, very drastic reduction of internet speed. So what you see on your computer can easily be multiplied out, several orders of magnitude when you're testing for mobile devices too. So yeah, that's a good point. Okay, yeah. Yep, that's a good point. Quick summary, it might be more expensive to hire React developers to run up 100% of a static site versus not having to hire React specialists to make most of your site and then only bringing them in for one small portion, which is a valid point. Yes, the question was, how would you render selective components instead of the whole site? For this approach, it's the default, and honestly, the only way to do it. So the plugin that I showed, you link up the name of a custom element with a component. And wherever that custom element shows up in your HTML code, it will rehydrate. And wherever it doesn't, no React will run on that code whatsoever. Yeah, true. Yeah, this is not dependent on Spike. Reshape is its own completely separate project. It is simply an HTML parser, and it can be combined with any type of website at all. And in fact, for this site, one of my technical requirements was that it had to use middleman. And so it uses middleman, and when middleman is done with its HTML, it passes it off to an independent process that just runs Reshape, parses the HTML. Middleman doesn't choke on the custom elements because they're valid HTML. Reshape takes the custom elements and rehydrates them, and then it comes out a little bit slower that way. Better if you don't have to do it. But yeah, you can use Reshape anywhere. It's not like tied into any specific philosophy or like static site generator. Oh, yeah, sorry. I mentioned middleman, and the question is, what is middleman? Middleman is a static site generator written using Ruby. It's pretty good. It's more general purpose than Jekyll. Jekyll is like very blog targeted. Middleman is a little more generic, and I would say a little bit more powerful, but it has a little steeper of a learning curve. At this point, I don't know if I'd recommend it because there's no reason to bring Ruby into your development workflow unless you have a lot of Ruby developers. But people working on websites tend to not have Ruby expertise out of the box. So I don't think I would recommend middleman. The reason that the requirement was made for my site was that the company had a lot of Ruby developers that were more comfortable with Ruby than with JavaScript. So it kind of depends on your problem. Does that answer the question? Okay. Yes, we had a couple over here. Yeah. That's a really good question. The question was, how do you manage state between different portions of the site that are rehydrated? I haven't actually run into that problem yet at all. So in any spot where I'm running a component that's complex enough to require state that's shared with outside ones, it's usually wrapped in a parent component and it passes the state down. Like there are a bunch of components in here, and I wish I had React DevTools running, but I don't because it's production. There are a bunch of components here down to form field areas and specific form fields that all have their own state. But ultimately, since it's all part of one trial form component, the state's managed at the top level. I don't have places where I have one over here and one over there that are totally separate that need to ping back and forth. I would have to think about how to work on that one. I think probably the easiest way would just be to encapsulate them both in a parent component and use that to do the trick. And if you've gotten to a point where you have so much state that you need to encapsulate your whole site in a parent component, it's probably time to, you probably have a web app and it's time to just use React for everything, which is perfectly reasonable. Yes, right here. I think the question was, what about caching? I don't think caching has too big of effect on this architecture. I mean, it's important and you do want to think about caching, but it sort of is a separate topic. And none of these ways of building sites would have particularly differing opinions on how you would do caching on the client side, at least, as far as I'm aware. I'm sorry, was that not the right question? Yeah, caching definitely makes things more complicated. When I mentioned it earlier, I was talking about server-side caching for something like WordPress, which is probably something you want to use, but it definitely makes things more complicated. But the benefit is you certainly get a better performance out of it. Okay, I think I had some more. Yes. So the question was, does your caching technique differ between static and dynamic portions of this website? The whole website is static. There are no dynamic parts. Even the React components are rendered out as static code. The resulting page is fully HTML. Once the page loads and the JavaScript loads, then the component boots up after that. Yeah. You would redeploy the whole page. I don't do caching changes based on small sections of the page. I'm not even sure if that's possible. If it is, then today I learned something. But I think if you're going to change up your client-side caching, it's either the full page or it's not the full page. So I couldn't say, like, uncache the right side of the page. You know what I mean? I don't think. So if the form changes, then both my static and my rehydrated component change because the component changed. And so then the page would get invalidated in the cache, the whole page. Sorry, was that not a good answer, or is that not what you're after? I feel like I'm having a little trouble. Okay, am I out of time? Was there anything else? One more question. 0 more questions. Okay, good. Well, thank you guys so much for listening to me, and I really appreciate it.